Alright guys, well I shot a little video out in the shop of this same subject and not sure I was really happy with it, so let's start over again here and maybe we'll include a little bit of it, maybe we won't. But anyway, my beef today is the same as my beef has been for a while with this, but it's this misinformation on the lists. And you know, as we all know, that if it's been posted on the internet it must be true. So I monitor quite a few user groups, and all right here on IO groups, and I'm looking at the Sheldon list right here, which is kind of what I'm going to focus on today. But um, I'm looking here, and I'm looking over the last 3 or 4 days. I guess actually I'm looking back to the 16th of February, but this is just a quick touch on it. Just the last few days is kind of what interests me. But there is so much information and so much sales pitch and so much noise here that we all need to learn to ignore a good portion of it, because it leads people astray so badly that it quite literally just pisses me off, and there's a reason for that. But anyway, before I get going, I want to go back here in this one that I'm looking at. Why gentleman was they were talking about transposing gears on the lathes, on the Sheldon lathes, and of course that's kind of what started this whole thing about how great converting a Sheldon lathe over is to CNC, and all the misinformation that's being put out there about that. But I want to go through several of these little listings here. Gentleman here talking about transposing gears, wanting to do some threading on a rifle barrel, or rifle barrels, or whatever the case may be. I will caution, and I've played gunsmith, as a lot of you know, for about 30 some years, and there's some talk about converting a firearm over from its original caliber to 7.62 NATO. I would offer a caution there to very carefully check your pressures on cartridges, because from what it originally was chambered in and what you are wanting to chamber it in 7.62 NATO is running, if you look at SAMI specs, approximately twice the pressure specifications for that cartridge, or for those two cartridges. So I would say be very, 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 very cautious of what you're doing there, because if that works to your satisfaction, you get it all together that you want, I would caution you to be very careful that it does not come apart when it is tested. So anyway, that's just my little thing there. Um, you know, this is true with all of the lists that we monitor, all of these user groups. There's a tremendous amount of good information out there. Um, but there's also a whole lot of noise. You know, I kind of got involved in a discussion from 2 days ago, and now what I look at, and it's not just been on that discussion. It's been on several different topics, but this started out about 2 days ago, and I'm on the fourth page, which is um, the 80. You know, there's been 80 messages since then, and I'm going to honestly say that a good portion of these are just quite literally noise. There's just not really any useful information there, although all information can be considered useful, but there's a lot of this that I consider to be just flat misleading. So let's go on up here, and this started on, and this kind of relates back to this about this metric threading. Um, we see a list right here, or a topic right here, about converting it to CNC, because it's going to solve all your problems. All your issues are going to be gone if you just follow my advice and convert this over to CNC, is what this poster's telling. And virtually every time a new topic comes up, somebody's looking for parts, or somebody's looking to do something that can be done with a set of metric change gears and a new banjo potentially, which granted those are expenses, but they're not nearly the expense that you're going to run into converting to CNC. So, and you know, I'm going to cover some of these. You convert it to CNC, you're right, no metric change gears to worry about for threading. And yeah, it just becomes a advertisement every time a new topic comes up, is we need to take our machines and tear them apart and convert them to CNC, because that's going to solve all our problems. Um, okay, then we went on to a 10-inch clutch, stuck clutch on a 10-inch Sheldon. Now I did post that I had a video of that, and I normally will not post any of my YouTube video stuff to groups. I mean, I have in the past, but I try and refrain from that. I don't. That's not what they're for. They're for the free exchange of good information, hopefully. And the only reason I posted this about the clutch is because I had shot a video of it being of me showing operation of that clutch and then disassembling off of the one Sheldon that I'm rebuilding. Now, there's a whole bunch of things along the way. There was the convert it to CNC topic that popped up immediately, but then there's some say it's got left-hand threads and some say it's got right-hand threads, and heat it up with a torch and get your 2-foot pipe wrench or your pipe wrenches and your 2-foot cheater out there on it and everything. So I did post a information, my videos on there so they could go and look at that, and hopefully that helped. But yeah, there's stuff going both ways, and that can be, confusing on those. But there's a whole bunch of posts on that some are helpful, some are not. So we look at those. But then the ones that I got involved in, and I should have probably just kept my mouth shut and not just ignored it, but it's a constant sales pitch for converting things to CNC. And the reality of it is, and I posted before, I did put a post up that showed how I felt about that and why it wasn't always such a good idea, and then I took it back down off of the list because I just thought I wasn't going to get, I don't want to go down this rabbit hole, but there was a couple of people that did comment on it before I got it pulled back down again. And we've gone through spindle bearings. And one of the things that I did bring up or did think about with converting these to CNC, and if a person wants to go down the rabbit hole of converting a lathe to CNC, that's fine. I've done that. I've got my little Grizzly G0602 that I converted. I bought that lathe specifically for conversion. I'd already converted a real early vertical mill, which was also a Grizzly. It was a Taiwan built Grizzly, whereas the lathe was a Chinese manufactured G0602. And so I've got a little bit of experience with CNC stuff too on a small scale. I run those. I run some parts off of them, as those who watch this channel know. Market them through my website, that type of thing. But I try not to push that through the list. When I post something to any of these lists, I try and make it to where I have something that's going to be beneficial to the question that's being asked. I look at how active I am on some of these lists, and here on this Sheldon list, I looked, and I've been a member of the Sheldon list since 2002, which means 23 years, 2002, 2003, at 22 or 23 years that I've been here, and out of that I have a grand total of 20 postings as of this morning when I looked. So I don't post too much on these messages. There's a lot of good information in the photo sections, in the file sections, and I can get those from that's why I'm a member of a lot of these lists. Every once in a while I will ask a question, but usually when I ask a question it gets inundated with noise that may or may not be helpful. So anyway, thing came up about spindle bearings, well, on the bigger lathes, and the Timken numbers for those are the Timken barrels that were used on them, if they were Timken, whatever they used on them, are a high precision bearing. Those bearings, I think they're in it's been discussed here and was just discussed with this, is in the $400 range for each one. So you're going to spend $800 in shipping, or whatever it may be, to put in your bigger lathe if you're going to convert it to CNC, because a lathe that's 20, 30, 40, 50 years old, those lathes are going to be worn enough that you're not going to get the precision that some of these people are saying that you can achieve with a Sheldon lathe by converting it to CNC. So you added another $800,000-900,000 there just for spindle bearings before you start doing anything else. We'll take that as one of those things. And the one I kind of got involved with was somebody asking about source for a compound rest. Well, there again, the big push came about convert it to CNC. So that's about the time that I chimed in, and I said that there was, where is it? I keep hearing the praises of CNC on a Sheldon, but as with everything, there are also downsides that would be good to hear about. What are they? Any videos of a Sheldon conversion running parts or setting up tooling to run a job, costs, the learning curve that goes with it, and of course there was no real reply to that to me. There was a reply to another individual, kind of asking the same things, but was really gung ho about doing a conversion, and we all have to learn someplace. And I think this individual maybe hasn't done the research yet to really find out what's involved with this, but he's really interested in this. Now, where I run into problems with, and I ran into this years ago with the shop that I started out in, and after I left, a year or so after I left, he closed that shop and he sold that shop or had that shop for sale. Now, if someone like me who was in the industry knew what was going on, I could go in there had I been interested, and I could have bought that shop out. And if I was successful, that's great. If I failed, that was on me, because I already knew what I had going in. I knew what was going on in there. The individual that bought this was a young man that had saved a little bit of money and had some money from inheritance and could have done pretty good with his life. You know, could have had a pretty good life. He wouldn't have been rich by any means, but he could have invested that money a little bit and been careful and maybe worked for a while longer and could have had a very good life. As it was, he got taken to the cleaners. He didn't really have a clue what was going on, which was his fault. But by the same token, he was taken advantage of extremely, to the point where I would say he was scammed, basically, into giving his money for this business and the contents of it that were not worth nearly the way it was presented or what it was. And ultimately, he lost everything. Lost everything. Managed to go back to work for somebody for a while, and he actually passed away here just not too long ago. But that's my problem with a lot of this stuff. If somebody knows what they're doing going in, wants to go down the rabbit hole of converting something to CNC, doing something different with a machine, that's entirely up to them. But they need to have a chance to be able to make informed decisions. And what we're hearing here is just a constant sales pitch of you need to just convert your machine over to CNC. Okay, so I'll kind of leave that at that. Anyway, we go on with this. There was a post back by the gentleman that's pushing CNC stuff, and it's an older gentleman, and I have a lot of respect for what he's been able to accomplish in his life, and that he's been able to do this as I do for a lot of these older machinists that are on this group and are very knowledgeable and have knowledge to share if they will fairly share it. And he kind of gave a overview of what was involved. In my opinion, was kind of whitewashed over, you know, what you really had to do to it, and, you know, a couple of downsides. You're going to lose the ability to open the half nuts, and which, if you've got a full CNC conversion, doesn't matter, but didn't give a real, I feel, accurate description of what was going on. And you know, it just doesn't work for these guys when this stuff gets recommended and you're not honest about it. And, you know, like I say, I kind of ask if there was any videos and things like that of this going. In this day and age, everybody's got a smartphone, everybody's got computer access, otherwise you wouldn't be on these user groups, things like that. So you should be able to back up what you're claiming by at least giving some examples of stuff, and there's not anything being shown. So anyway, that's kind of the way I feel about it. I guess if I go back and read my previous post, I'm in my previous post I was playing devil's advocate. I mean, no disrespect, in my opinion, the oversimplification of a CNC conversion and its benefits to the average individual or small business who has just acquired a Sheldon lathe the way it is being presented here is doing them a great disservice when they're simply looking for parts to help them have a functional machine for their hobby or small business use. I run both a mill and a lathe CNC conversion that I built several years ago on Grizzly machines. The mill was a manual column mill I used for several years before converting it, and the lathe I purchased new for the conversion. Both running Mach 3, which is at that time was still a preferred software. I'm aware of Acorn and Mosso. Tormach is running their version of Linux. This is my opinion and observation, so anyone can take it for what it's worth. Software is relatively inexpensive or free, so not really an issue until you get to CAD/CAM, of which can be fairly inexpensive unless you want something that works. I personally use Fusion 360 and have the legacy pricing, which is still a few $100s a year. Hardware for the conversion, ball screws, nuts, servo motors, in my opinion, the least expensive option, although I still use steppers on both my conversions, and all of the rest of the bits and pieces, I would guess at least $2,000, and I'm going to say it's more than that now. Tooling will need to be a dedicated interchangeable system with a dedicated holder for each individual tool, probably with carbide inserts, if you expect any long-term repeatability. Cost probably more than the cost of the conversion, and for that I'm going to say you're going to want at least 10 or a dozen tool holders by the time you put or interchangeable holders by the time you put the tool holders themselves in there, and carbide inserts and extra carbide inserts. On a 10-inch machine I run AXA tool posts. On the bigger machines, on the 13 inches, 12, 13, 15 inches, you're probably going to go to a BXA. I'm going to guess those are more. I think AXAs were in that pretty close to $100 a piece, if not more, for pretty close to $100 a piece for standards using imported stuff. You're going to want at least a dozen of them, I'm going to say, and that's not enough, so you're going to be a couple $1,000s there, well, 1,200 if you're using AXA, probably 1,500-1,800 if you're using BXA holders, and that just gets you started. So that's going to be a big expense before you get any electronics, before you get a VFD hooked up, have a three-phase motor set up for it, do all the bits and pieces, do any other repairs that need to be done on the machine just to bring it up to fairly good standards, and they're all going to be worn. I mean, we can use spindle bearings as an example. So what the average guy, in my opinion, wants in their shop is to turn one or two of an item for whatever project he is working on, then move on to the next part he needs to build. And with a CNC, has lost the ability to turn the handles and feel the depth of cut for that last half thou. And the idea that you're going to run 1,000, I put 1,000 parts. The claim is 10,000 parts. You're going to write the code once, and you're going to run 10,000 parts and have the ability of the machine running lights out is unrealistic on a Sheldon. These things can be done, but if you're doing a run of even a few hundred parts on a regular basis, then they're being done on a machining center with stock feeders, probing tool turrets, and lubrication systems. From what I've seen, most production CNC shops still have a space somewhere in the shop that holds a manual machine like a Sheldon that does what it was originally built to do and does the job better than a CNC. Just my opinion, and I signed it. Now, I will stand by that. You're going to have several $1,000s invested in a machine. The build and the learning curve is going to be at best a year, and I'm going to say closer to 2, before you're to the point where you can start to maybe do something that you could have done if you would have just done a simple repair on a manual machine. And it's going to not do everything you want it to do. You're going to lose that manual machining ability, at least to a certain degree, and guys are running them and saying, oh, no, they can run them manually, and you can run them manually. I have cut some stuff manually on my CNC stuff. I don't like it. It doesn't work well. So to me, it's a bad sales pitch. So some of the responses, well, if you have a lathe, and this is from John. No, John, respect him. Good machinist, been around for a long time. Says if you have a lathe without a taper attachment, then CNC can help with that. If you have a machine with an imperial lead screw and need to cut metric threads, then CNC can solve that too. Both of those things are true. I have a taper attachment on the Sheldon that I'm running now, my older Sheldon. And your what your use for a machine is going to vary. Some guys will probably use a taper attachment a whole lot. Some guys are not going to use them hardly at all. I've had the Sheldon that I've been running for about 30 years now, pretty close to 30 years. I've owned it and had it here at the shop. I can count the number of times that I've used that taper attachment for what it was intended for. I can count them on one hand, and I'm not sure I'm even using all my fingers there. Okay, I don't use a taper attachment hardly at all. Now, I will convert it over and put it on my new machine, on the machine that I'm rebuilding. They're a cool attachment to have. I will play with it a little bit more and try and get a little more use out of it. But in reality, could I get by for the most part without a taper attachment? Yeah, I could. As far as cutting metric threads, same thing. Change gears in a banjo, you're going to do that a whole lot cheaper than you are with a CNC for the amount that you're going to do it. If you're going to cut a lot of metric threads and you don't have that set up, you can say that, yeah, CNC would save you time in that respect. By the same token, for the amount of metric threads you're cutting, if you're cutting that many of them, it's not going to take too long and you're going to get good at it, just changing gears and running a different banjo on it. It might be a pain in the ass, but not really that big a deal in my opinion. So there's that. So, that's kind of for what it's worth. And I realize I'm kind of rambling here, but to me this is kind of a sore spot after a while, I guess. It tends for me not to pay any attention. I actually was going through and hit the unsubscribe button the other day and then thought better of it, because I do use it for file section, photo section. This is one of the very few lists that I monitor that is still on where I still get the messages emailed into me. I belong to the Atlas list, couple of the Atlas lists I don't get. If I'm interested in anything, I go over and I search out what's going on, because there's way too much noise going on there, and it's almost getting to where there's too much noise going on here too. This is from the original poster, and he has posted some pictures of his machines, and we've discussed it since then. And I've communicated with him privately, apologizing for sending this discussion off into the weeds. But here's his post from, when was this? Was this yesterday? Was this yesterday? I don't see. Yes, this was yesterday. What he posted is, not one response in this chat has addressed or even mentioned anything about my search for a compound. I'm not interested in upgrading my Sheldon or any of my other manual machines to CNC, nor did I allude to that in my initial post. Someone chimes in about Linux on virtually every thread within this group, and I suspect that is not what most of the members are interested in. Please take the Linux discussion to a dedicated thread, as this degrades the quality and benefit of the entire group's discussions. And that's been my main complaint all along with all of this. That's... People just want help with what they ask about. They don't want to be steered off into the weeds with some other thing that they're not interested in. And, that's the big deal. So, anyway, since then he did post a couple of pictures of this being broken, and of his part, and was very enlightening. And the reality is, he does not need a new compound at all. I showed him and it ends up the top of the compound had been broken off. Let's see, they're onto a cross-feed screw to somebody else on a lathe, and I'll talk about that in just a minute. But he did post a couple of pictures, and his compound had been broken out at the top where the T-slot is, and from the looks of it, to me, someone's just torqued it. May have been crashed and busted out the tool holder and everything off of the top, or at least cracked it to where it was welded back up very, very poorly. But it it was not a good repair at all, but it's one that's very easily repaired. What I sent back was, thanks for the pictures. In my opinion, that is an easy and inexpensive way to repair the previous repair, and would be better than trying to fit a replacement casting. Simply mill away the top of the casting and the welded up area down to the top of the T-slot and replace it with 2 pieces of steel flat bar. Drill and tap with probably 4 per side, quarter 20 socket head cap screws, adhesive thread locker, and then mill the top to match the original finish and finish as desired. You'll have a repair that is structurally as sound as the original casting without having to fit or refit or replacement. If this is not clear, stay tuned, as later today I'll be working on a video for my channel giving my opinion on the foolishness that happens on forums and why I quite often monitor but rarely post. Below is a photo of just such a repair, and I'll post that picture here because it can give a good idea of what can be done very simply on a repair. This is on a Atlas horizontal mill table that I'd bought, and it had already been repaired when I bought it. This is not one of my repairs, but it was very well done. I knew what I was buying when I bought it, and the only reason I bought it is this goes to the production mill, and at that time I was gathering parts, and I still am gathering parts for that mill. I started working on it, but since then I have found another table that's in original condition without being repaired. So this is actually spare to my needs, but it's going to stay in my parts pile for at least a while before I do away with it. So that was a solution, and he came back and said he thought he'd go down that path, because I think that is a very good option. You don't have to refit gibs, rescrape, or everything. I will say that I tell everybody that all of these machines are well worn, and people on the Atlas list, and I'm sure if you listen long enough, they'll tell you that on the machines they've got here. They're all proud of their machines and everything. They're all in excellent condition, and all of these machines are war. You know, we're talking stuff that's 50, 60, 70 years old, 80 years old. They're well worn. They've been used and abused. You know, they may have started out, the bigger machines especially tend to be in a little bit bigger or in a little bit better condition, I think, because they've been used in a production environment. They've been in a shop building parts, and while they are worn, they haven't for the most part probably been abused, because they've been run by machinists. They've been used to make money with, and they've been, or in military service, and they've been maintained, so they're in good shape. After all of these years, the smaller machines, especially like my EXL and some of those, they have been they started out in those same environments, but in the interim, why they've been sold or auctioned off to individuals for their shops, small, you know, the little auto repair shop down the corner where it sat in the back corner and gotten dirty and dusty, and once a month or something somebody'd walk back and turn it on and spin everything around and build a part or two or cut out a bushing or something like that. And you know, they figured next time they'd lube it or clean some of the dust off before they cranked all those handlers, stuff like that. So these machines tend to be abused, especially the smaller machines, like I say. So you know, when they tell you they're in excellent condition, they're all worn. You know, I haven't seen any of them that are not worn. So when you look at the videos and the pictures of the disassembly of the one that I'm rebuilding right now, that machine was in terrible condition. Still needs a lot of TLC yet, but it was, you know, it was worth scrap prices is all it was worth. And there's parts I don't have, there's parts I'm building for it, there's, you know, but we'll make a decent machine out of it, and it will be a excellent manual machine. Like I say, it's probably the one that I'll keep forever now once this is done. So then they're talking about cross-feed screws. Guy broke his cross-feed screw, dropped it. So I'm going to build new cross-feed and compound screws and nuts for mine. So that will happen hopefully before too long, but in the future that will be done. Now, there's a big discussion about redoing this cross-feed screw, and it appears his is 3/4 4 is threads on it. These are going to be Acme's. Now his supposedly is a right-hand thread. Both of mine are left-hand threads. Now I think all of the threads on my compound and cross-feed are 1/2/8. Now the one on at least the cross-feed is left-hand, and I believe the compound is going to be left-hand too. The way I'm going to build those is I will probably buy an inexpensive left-hand 1/2/8 thread to cut the nuts with for that not ball screw, but for the lead screw. So that's the way I will cut those for the nuts. Then I will fit the screw to them. When I'm looking at the one he's looking for is 3/4 4. My Sheldon cuts 4 threads per inch. So, you know, for me personally, and cutting Acme threads are a pain in the ass, but it's not that difficult. Left hand's not that much more difficult. You grind a tool either way, and you grind them, you know, you grind your rakes different sides of them, one right and one left. But and there again, we're back to the thing somebody chimed in with misinformation. To grind your tool, you're just going to grind you a high-speed tool, which is true. You're just going to grind, but they're saying, oh, you got to have a CBN wheel. Why in the hell do you need an expensive CBN wheel to grind a high-speed tool bit? Doesn't make sense. You know, it's bad information. So there's that information there. You know, but anyway, for a standard Sheldon, you could, you know, you can monkey around and cut your own lead screws for those. I'm going to cut mine. Like I say, they're 1/2 left-hand thread. We'll use a cheap imported tap to build the nut. Then we'll cut the screws to match them. I'm probably going to machine those out of 4140 pre-hard is probably what I will use. While I was out playing in the shop earlier today, I took a Rockwell file, my Rockwell files, and the lowest one I've got is a 40 Rockwell. If you run a 40 Rockwell across both my screw, it will grab there a little bit. The way it feels, I'm guessing it's about a 35 Rockwell. Took that same file and ran it across a big hunk of 4140 that I just purchased a month or so ago to go on the grown-up corn tool and cutter grinder. They're virtually the same, and it's a piece of 4140 annealed. You know, it may be just a little bit softer than that lead screw, but not very much. So I'm going to say if I take a couple pieces of 4140 pre-hard and thread them up, which they're a little bit tougher to thread, but not bad to thread at all, then that's going to do everything I want it to do. I see somebody here talking about cutting one, and he's talking about using stress proof. I've run stress proof. I run stress proof for firing pins primarily. Works real well for that. Impact resistant, holds up pretty well for that application. I'm not really sure that's what I would choose to use for lead screws. You know, it works better probably than a lot of the just screw cutting type of steels that you would run on a screw machine. But those are actually fitted for a put it in once and that's where it stays for the most part type of screw. For a moving screw that, you know, is going to see constant traversing back and forth across that nut, even though it is a brass nut, I would kind of question the hardness of it, although I haven't looked into the properties of the stress proofs that he's listing here. He's listing A311 and 1144. They do thread really nicely and everything. I'm not sure that would be my choice for long-term longevity on them. So anyway, I'm kind of rambling. This has rambled on too long, but there's, you know, every once in a while something gets a little under my skin and I tend to kind of go off the rails with it a little bit. So hopefully you can find this a little bit useful, entertaining at least for the afternoon. So comments, suggestions, leave them in the comments section for me below, guys. And as always, thanks for taking the time to watch.